moles, atoms, and atomic mass. So let's do some conversions here. What we're going to do is convert moles into atoms and into the atomic mass or the mass of any element. So let's look at the relationship first. 1 mole is equal to 6.022 times 10 to the power of 23 atoms or molecules or whatever it might be, and that is equal to the atomic mass of the element and whatever that element might be. Okay, you can use these relationships as very different kinds of conversion factors. So 1 mole over 6.022 times 10 to the power 23 atoms, or you can do it the other way depending on what you're converting. So if you're wanting to convert into atoms, then you will use the one that I'm writing right now, or you can also convert into grams, and because grams is the atomic mass, okay, that you get from the periodic table. So if you're calculating for mass, then the mass will be on the top, so atomic mass over 1 mole, okay, of any substance. So these are your conversion factors that you can use using all of those. So let's go ahead and do a problem now. So problem number 1, how many molecules are in 5.0 times 10 to the power negative 10 moles of sulfur dioxide? Okay, simple, straightforward. Again, you start with what you know, which is 5.0 times 10 to the negative 10 moles of sulfur dioxide, SO2. Now you have to convert into molecules. So your molecules should be on the top, moles should be down here, and in 1 mole there are 6.022 10 to the power 23 molecules. Once you do this conversion and the calculation, your answer should come out to be 3.0 10 to the power of 14 moles. Okay, and moles get cancelled, so it's molecules. You should do the calculation just to make sure that you get the same answer, because again, remember, sometimes the exponent doesn't work as well in your calculator. So learn how to do that. Let's try another one, and in this one we're going to do the reverse. How many moles are in 7.0 times 10 to the power 21 particles of dust? So it doesn't really matter what you're converting. The point is that you have to use Avogadro's number. So here we start again with what we know, which is 7.0 10 to the power of 21 particles, and the number of particles will go at the bottom because we're trying to calculate moles. So moles on the top, particles down here, and in 1 mole again there are 6.022 10 to the power of 23 particles. Okay, so particles get cancelled, and then the moles will be 1.2 times 10 to the negative 2 moles of dust particles. Okay, let's do another one. Now we'll get into the mass. So mass to mole calculation now. Okay, so how many moles of calcium ions are in 425 milligram of calcium ion tablet? Okay, so in this case now you have one more conversion to do because this is given in milligrams. So your strategy is to convert milligrams to grams and then to moles. Okay, so you start from 425 milligrams, convert that into grams, and then convert that into moles. So moles goes on the top and grams down here. You know your units are in order, okay, because moles is your final answer here. Then you fill in all the blanks. In 1 gram there is 1000 milligrams. In 1 mole of calcium ions there are 40.08 grams. Again, this is coming from the periodic table. Once you do the entire calculation, your answer should come out to be 0.0106 moles of calcium ions. Let's look at another problem. In this one, we're going to do the reverse of that, which means we'll calculate grams. So how many grams are in 0.462 moles of helium in a balloon? So now this is a moles to grams calculation. You start with what you have, which is 0.462 moles of helium. To convert that into grams, you need grams on the top, moles down here. And so in 1 mole, there are 4.003 grams of helium. Again, this is coming from the periodic table. Okay, and so moles get cancelled out, and the final answer should be 1.85 grams of helium. So you can see in all of these conversions, you just do it as a dimension analysis. You keep on the top what you need, or you start with what you have, and then you keep on the top what you need, and then cross out from the bottom. Okay, one more problem. So in this problem, what we're going to do is take one step further and do one more calculation. So for example, in this one, how many atoms of gold are in 62.0 grams of gold? Okay, so now your strategy will be to go from grams to moles and then to atoms. Whatever you have in grams, it's much better to go to moles and then to atoms. And if you're converting from atoms to grams, go through the moles. Okay, that is the best way to do this. So 62.0 grams of gold, convert that into moles, and you can do that from the periodic table, and then convert the moles into atoms. Okay, that is how you'll set up this problem. And so in 1 mole of gold, there is 196.97 grams of gold, and then in 1 mole, there are 6.022 10 to the power 23 atoms. And so grams, moles get cancelled out. When you do the entire calculation, your answer should be 1.896 times 10 to the power 23 atoms, which is equivalent to 1.90, bringing it down to the right significant figures, 10 to the power 23 atoms of gold. Okay, and so this is how you will do all these conversions between atoms and moles and grams.